Hi everybody. I wanted to go over your 10.3 exit slip, which was base E of logs. I felt like a lot of these questions, a lot of you did well on, but I also do feel like there's things that I really want to point out to you that I can't necessarily do just from an answer key. So let's take a look at the first exit slip question. You write the two following log equations as exponent equations. So part A, this question was probably one of the most missed when I was grading the exit slip. Many of you assumed that when you saw this problem, that you thought that the base was E because the unit was about base E. I purposely put question A here to see if you were paying attention. This is not base E. If you just see the word log, you assume that the base is base 10. So a lot of you wrote this on your exit slip. A lot of you said E to the negative second equals 1 over 100. But if you check that in the calculator, guys, e to the negative second isn't even close to 1/100th. So this is wrong. However, if you had put 10 to the negative second equals 1 over 100, that is a correct statement because this time the base is 10, not e. If you think about what 10 to the negative second is, 10 to the second is 100, so a negative exponent has the reciprocal, so this is a true statement. Part B, a lot more of you did get. When you see ln versus log you assume base 10. When you see ln, you do assume that this is base E. So this one, if you want to change this into an exponential equation, it would be E to the fifth equals 148.413. And again, if you want to check that in the calculator, plug in E to the fifth, you will get a true statement here. I do like overall how many of you did know that this number right here and this number right here was the exponent because of my obsession with saying logs are exponents. The second problem on the exit slip, I asked you, and get rid of this here so you can actually see the question. Technical difficulties. To see if you really understand to convert from an exponent to a log without a calculator, please complete the following problems. So part A asks, please rewrite the following log equation as an exponential equation. So if I'd like to change this to something that's exponential, I need to figure out what the base is and what the exponent is. So we're taking a look at this situation right here. The base of this log is A, so we'd have A to the logs equal exponents, so C must be my exponent, so A to the C must equal B. This is what I was looking for on your exit slip. Part B was more missed than part A. Part B, if I'd like to change this to a log equation, we're going to do, so to read logs, it's log base something equals the exponent. So in this case, the base of my exponent is n, so it's log base n of something equals my exponent, and my exponent is x. So we have log base n of y, which is called the argument, equals x. That's what I was looking for on part B. Now a lot of you got these right, so great job. I know you know how to exchange between exponents and logs. You would like to invest $14,500 in an interest rate of 5.2% at your local bank. Find the balance of your account after 10 years if it's compounded quarterly, and then if it's compounded continuously. So, again, I did see a lot of correct answers, but I did see some that were a little bit off because of rounding, and I also saw some that were off by quite a couple $1,000s. So I would really consider getting your work out from when you did this exit slip to see maybe what you did wrong the first time if you did get these wrong. So if we're finding compounded quarterly, that is using this equation. And P represents the amount of money you're starting with, which is the $14,500. The R represents the rate that you are putting your money in at, or how much your interest rate is, which is really 5.2%. But 5.2% as a number, you move the decimal over twice to the left, is 0.052. So please check to see if you had the correct rate. Sometimes people get this problem wrong because they have 0.52 or plug in just 5.2 and didn't change it to a regular number. So that might be an issue right there. N represents the number of times a year you're taking out your money, or you're compounding your money. So quarterly represents that you are taking it out 4 times a year. So N is 4, and the amount of time that passes is 10 years. So if you plug all this information into your formula, we'd have 14,500, 1 plus 0.052 divided by 4 to the 4 times 10 power, or to the 40th power. So unfortunately, I don't have a TI calculator on this computer where I'm making the video. So let me explain what I would do if I was plugging this into my calculator. I would follow the order of operations. I would do this piece first, take 0.052 divided by 4, and I would not erase your answer. I would completely keep it in the calculator. I would add 1 to that answer next, because you're following the order of ops. Then, without erasing this answer, I would raise it to the 40th power, so that would be like a little caret to the 40th power. And then, after you get that answer, don't erase it in your calculator, multiply it by $14,500. And if you did that correctly, your answer should have been $24,307.81. So it's important to not erase anything along the way. You want an exact value of money, so you don't want to erase or round along the way. The second example, if you would like to find everything continuously, your equation changes a bit. This is if you're dealing with monthly or quarterly or semi-annually or weekly. But as soon as you see the word continuously, which means the money is constantly compounding, it becomes this equation. A equals PERT, P-E to the R-T. So everything is the same from this information. So what we need to do is plug in A equals the amount that we're starting with, E, which is just a number, to the rate, 0.052, times the time, which is 10 years. So I'd plug this in directly as you see it. Just make sure when you're plugging in the calculator, I would put parentheses around these two, because these need to multiply before you raise e to the power. If you do that correctly, your A value should have been $24,389.40. On this one, there's a little bit of a rounding issue. For some of you, you had 24,388. Please make sure that you are not rounding e to a power. Make sure you plug it in completely in your calculator. Now, this last problem on the exit slip asks you to say, if you were to graph this function on a future test, please answer the following questions, because this is what you'd have to ask yourself on the test in order to get this right. So the first thing I asked was, what is the parent function of the function above? Parent function means the most basic function without shifts. So if I'm dealing with the most basic function, that would be just ln of x. No x plus 2, no plus 1. This is your parent function to what is above. The two key points of your parent function. If you're dealing with any type of log graph at all, log graphs always use the 2 points 1, 0, and then the base, 1. Some of you had this flipped. Some of you had 0, 1, and 1, the base, but that's for exponential graphs, not logs. So some of you had this right, though, the correct order. But what happened for a lot of you was you assumed the base was 10. But if you see ln, you assume that the base is e, which means that your two key points are 1, 0 and e, 1, which really are 1, 0 and 2.718, 1. I was looking for one of these two answers on the exit slip. Where is the graph shifting? Well, a lot of you got this right. You looked at the x plus 2, and you said that means I'm going to the left 2 units. Then you saw the plus 1 and said up 1 unit. Both were correct. Part D, what are the two key points after you apply the shifts? Well, if these are my two key points originally, I'm going to apply this. So if I'm going from 1, 0, my shifts would be left 2 would end up at -1, and up 1 would be at +1. So this was one of your coordinates. And if your original point was 2.718, 1, you apply the shifts. If you're going left 2 from 2.718, that's really 0.718. Then if you're going up 1 from here, that would be 2. So here were the two coordinates I was looking for. So these are the two coordinates that you would use to graph your log if I actually asked you to graph here. This problem, some of you might have noticed you got a 3 out of 4 or a 2 out of 4. That's because you might have accidentally had the wrong thing for the parent or the key points, but you applied the right rules to it. Part C and D, a lot of you got left 2, up 1, and applied that. So I gave you some partial credit there, but please be careful on a future test. All right, guys, I hope this was useful. Feel free to rewatch. I'm here if you have any more questions. Thank you.